Let's have a look at example 1. It's on page 464 and 465. For each of these geometric sequences, write down the first term, the common ratio, the 10th term. Okay, so that's set A there, set B, and set C. And this is the example in the book. Let's go through it together. Okay, the first thing we need to find is the first term of this one here. Well, that's 2. It's the first number there. For this one here, the first number is -3. And for this one, the first number is 16. So that's pretty straightforward. We've got to find the common ratio R. Well, the common ratio for a geometric sequence is un plus 1 over un. So that would be the second term divided by the first term, and the third term divided by the second term. That should be the same number for it to be a geometric sequence. So the first one is 6 divided by 2, and that gives us 3. The second one is 6 divided by -3. That gives us a -2. And this is 8 divided by 16, and that gives us a half. Okay, and then we have to find what U10 is. Well, if we know the first term and we know R, we can use the formula for finding out the 10th term. Okay, so for example here, it is U1, which is 2, times R to the power of n minus 1. Okay, so 10 minus 1 is 9, R is 3, and U1 is 2. Similarly, U1 times R to the power of 10 minus 1. So that's 9. That's the answer there. And C, U1 is 16, R is 0.5. It's okay to leave it as a fraction, just 1 on 2. And that's to the 9th power because it's 10 minus 1. Great. Okay, let's have a look at question 2. Caroline is starting a new job. She earns €48,000 in her first year, and her salary increases by 5% each year. Show that Caroline's annual salary follows a geometric sequence and state the common ratio. Calculate how much Caroline will earn in her 5th year at work. You must be careful with questions with have year, first year, second year, because sometimes you see expressions like at the beginning or at the end of the year. In this case, it's a bit more simple because we can say that the 48,000 is U1. That's the first term. It's not changing throughout the whole year. The change will happen on January the 1st of the following year. If it increases by 5% per year, 5 over 100 is 0.05, and so we would multiply. It's increasing, so I multiply by 1.05. So that shows that as 1.05 here. That's R. We know U1 is 48,000. Therefore, using the formula for U5, it's asking us the 5th year. That's U1 times R to the 5 minus 1, or the n minus 1 there. So U1 is 48,000. That's 48,000 times R, which is 1.05, to the power of 4, because that's 5 minus 1, and that comes as €58,344.30. Now, keep in mind that in the IB exams, you need to use 3 significant figures. That is always the case. With money, however, you must put 2 decimal places. Okay, you've got to put 2 decimal places when you're dealing with money, unless the question says to round it to the nearest dollar. Okay. Let's have a look at 3. The third term of a positive geometric sequence is 63, and the 5th term is 567. Find the common ratio in the first term. Okay, so we can follow this. We know U3 is 63, and U5 is 567. Okay. Now, let me just write something down here. Well, we already have it over here, really. We know that this is what we want to have a look at here. U3 times R must equal U5. All right? Because U3 times R would be U4, and U3 times RR would be U5. So R squared equals U5 on U3. Okay, I think that's a better way. That's basically what they're doing here. But if you see it a bit more clearer, because these terms are so close together, we can just have a look and say, well, U3 times R is U4, and U3 times R must be U5. We know U3 is 63, and we know U5 is 567. So R squared equals U5 on U3. Okay, and that's U5 on U3 there. U5 on U3 is 9. That's R squared. Okay, R squared is 9. Then we've got the answer if it's a plus or minus 3, but it does say in the question positive geometric sequence there. Okay, so if it's all positive, every term is positive, so it's got to be 3. And it says, so R is 3, and then you put it back into the first equation. Well, in our case, we can also say if U3 times R equals U5, then we can also say that U1 times R equals U3. Okay, and we know R, we know U3, so we should be able to find U1. Now, R squared there, we know R is 3, so that's 9. So U1 is U3 divided by 9. And U3 was 63 divided by 9 is 7. Okay, there you go.